beautiful robot.
What is its name?
Robot or Sandbot.
Very beautiful eyes.
Yeah. And while you're walking, this robot as well is scanning the environment. Yes, like this. You need to remember how to move each
Now it follows the same path?
Yes,
You moved it.
the same path where I define those.
Yes.
Where we can print different parts.
It is the outcome of 3D printing?
Yes, it's scanned. We have also scanning technology. Here one is table technology, one on table. We have one mobile technology.
Okay, beautiful.
Okay, so hello everyone. My name is Mantas. I'm responsible for these laboratories. I am the head of laboratories of mechatronics and robotics, as well lecturer, which is giving lectures on robotics, applied artificial intelligence, and so on. And as well, I'm a PhD student, which is my scope on industrial robotics as well in mechanical engineering field. So here you are in the laboratory of industrial robotics. Here you can see several robots. Like one is working already, doing some manipulation tasks, pick and place tasks to place one object from one place to another. Well, students program this kind of movements in the code, and students also working on programming other kind of robots as well from other manufacturers, how to implement those in industries, in medical applications, in food manufacturing. Well, what we have in Lithuania or around the world. So it doesn't matter, those robots can be everywhere applied, for example, in security as well, in some exploration, like dangerous fields exploration, like volcanic, underwater, space exploration, like also in military, some zones restricted and so on, like mines, demining and so on. Here you can see like robotic arms, here you can see like mobile robots, which has also their own purpose. For example, they can follow me. I can show you how it's done. I'm just pressing this button. He scans my legs and he goes after me. Just like that. You can avoid obstacles, go around me.
Now,
You can try if you want.
me. My turn.
Yes.
How to start?
Just press the...
This?
Press not this one, green.
I can take your phone and capture you. Yeah.
So, yes.
Large start.
Yeah, you can go. And while you're walking, this robot as well is scanning the environment using one sensor, which you can see it's like...
Not hit by any obstacle.
Well, it's trying not to hit, but I see he's detected that there is obstacle and he stopped. So, well, you can just press button, you can control it by moving, So while you're walking together with the robot is scanning the environment, and you can extract that like the environment data and program for the robot specific.
It's like a pet.
Yes, yeah, it's a follower. For example, it's very good in
what are the
airports.
Applications.
What applications?
applications?
Yes, it is used, for example, in big industries, like in big warehouses, for example, in Amazon, for example, where all the packages are put on the robot, and the robot moves from one place to another. For example, for sorting, for putting packages in the storage or in the shelves, for example, and so on. Yes, we have few robots, these kinds of industries, but in Lithuania, for example, well, in Lithuania there are not many big industries where we need like big warehouses and these robots like needed, but there are some examples. In Vilnius there are one, for example, which is manufacturing covers of jars. Yes, and in one day they are manufacturing like 1 million covers of that.
Too much speed.
Like in one day.
Yes, in one day. So, and these robots are used for moving those packages, boxes from one place to another. They are working, I guess, like 6 or 8 robots like this, and they're doing the job. At the beginning, they said that employees didn't want to do this robot because why we need them? It's hard to program them or something. Maybe we will, for example, won't agree with each other, as an example. But later, they somehow, well, collaborated together, and when one robot was broken, just workers were very sad that Now we need to move those robots to one place to another. Simple movements. Well, can we program those movements, different movements? Very simple, like DJ. With colors.
The structure is like the simple, so that's why the moves are wrong.
Yes, it doesn't have like a very specific arms or something. Just like this, a penguin or something like that.
Yeah. It can also follow us, like
Yes, it has like a camera or some sensors, which can track the human as well, if it's needed. Or it can run away from a human if there is like a game specific to catch.
Can be a best friend for child.
Yes, or
Maybe.
elderly people as well. It's entertaining robots. Also, we're doing some science as well with that. Like detecting the interaction of human robot, for example, evaluate that.
And what are the other functions?
some more functions. You can which ones?
Yes, so well, there are several functions. So, for example, you can see here some sensors at the back. So it's used for running away from a human, as an example. In front, there are sensors for following human, for detecting that there is a human in front of it. For example, I can program this robot also by leading, just like that as well. Just too fast. Yes, I need to work with him very gently. This is one of the differences between collaborative robot and industrial robot. But I can use it like for simple programming. I save one point. For example, I can save another point here. I can save it as well. Let's fix.
Now it follows the same path?
Yes, it's
You moved
the
it.
same part where I define those.
Yes.
Maybe it's just possible to make it run.
Yes. And it follows the same loop?
Yes, you can program to do looping as well. So you need to find what to do. See, it's most so I can run again. I can put it again. And you see it stopped. It's very, very sensitive. It has very sensitive sensors, and it stops. I can run, and it will run again. You can stop. It stops. Yes. It's very secure to work with in one environment, in one work area. Then it will be good. Yeah, it's very often used in medicine as well to manipulate different some tubes and other.
Like filling it, yes.
Yes, to move from one place, and those movements can be very precise, and human hand can shake from steering or something. The robot can just move, place precisely objects to one place or another without any damaging. Where we can print different parts.
It is the outcome of 3D printing?
Yes, it's scanned. We have also scanning technology. Here one is table technology, one on table. We have one mobile technology.
Okay, beautiful.
As well, and one colleague before me scanned himself and printed. Yes, so. Yes, and we're using this laboratory for prototyping a lot. Well, 3D printing, the technology allows us easily prototype different parts, different objects. And for example, here also we have some parts for one robot we are trying. You saw
face,
the head of a wolf.
head.
I guess well maybe the legend of a Vilnius about Iron
Alice.
Wolf, yes.
And in the previous lab, on the whiteboard, there is a sketch of, I think, this.
Yes, so the wolf is our university symbol as well, and the wolf is the symbol of Vilnius city.
And this head is made by 3D
Yes, it's private printers.
Okay.
Did you see the sculpture of Vilnius, of the wolf near the Vilnius Science?
Yes.
So it's a replica, true replica. The designer of the sculpture gave us 3D model of this kind of wolf sculpture, and you wanted us to make it robotic. Yeah, to make some sounds, to move some legs. Yeah, doing something like that. Yeah, there are some
And it
other
is
projects.
under development stage.
Yes, it's under development stage. There are other projects as well for students. Also, we have like, yes, for example, the controlling the leg movements as well. It's under development stage. Also, we have some for manufacturing purposes like laser cutting, laser engraving.
And what is this?
It's a robot, it's a robot walking on 6 legs. Imitate the spider with 6 legs. As an example, it's 3D printed, also constructed by our students. But he didn't finish to launch it. But he made like a construction of it. For example, we have like original part which is damaged. Yes, we can scan it here with laser technology. Then this part is reconstructed and printed again. Yeah, scan it part. Then we can, on digital environment with some software, we can repair specific part which is damaged, then print it again. And this one is like scan it again, how it's scanned, how it's printed, and so on to check. Yes, so there are a lot of implementation of like scanning technology as well.
Interesting.
Collecting, assembling 3D printed industrial robots, what you saw on the first floor. So here's everything from 3D printed parts. We have here some standard motors, other components, screws, but everything, the construction mostly is 3D printed, yes. And
जी, तो आज मैं आया था विल्नियस गेडमिनस टेक्निकल यूनिवर्सिटी, जिसको शॉर्ट फॉर्म में हम VGTU भी कहते हैं। तो अल्हम्दुलिल्लाह काफ़ी इंटरेस्टिंग वर्कशॉप रही। डिफरेंट लेबॉर्ट्रीज़ को हमने जो है एक्सप्लोर किया। तो बहुत बहुत शुक्रिया मैं अपनी मैडम का भी अदा करके आया हूँ कि उन्होंने हमें अपॉर्चुनिटी दी। तो आप भी वीडियो देखकर काफ़ी इंस्पायरेशन आपने हासिल की होगी। और एक चीज़ ये मेरे माइंड में आई है कि टेक्नोलॉजी वाइज अभी तो ये प्रोटोटाइप सैम्पल्स थे, बहुत आगे हैं, स्टूडेंट्स भी बहुत आगे हैं और यूनिवर्सिटी मैनेजमेंट भी बहुत आगे है। तो इंशाल्लाह पाकिस्तान में भी इस तरह यूनिवर्सिटीज़ में काम होगा और स्टूडेंट्स जो है ना वो इसी तरह। अगर ये वीडियो बनाने का मकसद ये था कि जब मैं यूट्यूब पे इसको अपलोड करूँ तो काफ़ी स्टूडेंट्स जो हैं वो उनको आइडिया हो कि VGT यूनिवर्सिटी में किस तरह की लैब्स हैं और किस तरह यूरोप में जो है ना वो स्टडी होती है। तो अपना ख्याल रखें, मिलते हैं नेक्स्ट किसी इंटरेस्टिंग टॉपिक के साथ, किसी इंटरेस्टिंग वीडियो के साथ। अपना ख्याल रखें, अल्लाह हाफिज़।